In this experiment, we're going to be doing determination of molar solubility. This is going to be our setup. We have our burette, we have our ring stand, our burette holder, we have our element measure flask. Inside our burette, we're going to be having 0.05 or molar of our HCl, and then here in our flask we're gonna have 25 milliliter of our calcium hydroxide, and we're gonna be using methyl orange indicator. This is gonna look like as a saturated solution. We're gonna have our precipitate, that's gonna be our solid part. It's gonna look white cloudy, and our supernatant, that's gonna be on top, and that's going to be our liquid solution, and it's going to be colorless, and that's where are going to be working with the supernatant, just with the liquid part. So then we're going to be using a refrigerated cylinder. We're going to have 25 milliliter of our saturated calcium hydroxide, just the liquid part, and then we're going to transfer that to our element measure flask. That's going to be our analyte solution, and we're going to have the 2 drops of our indicator. Then we're going to titrate this. We're going to be doing titration, and our solution is going to go from yellow to a light red orange, and that's going to be our end point. So we want our end point to look like this color and around this pH. Then for our calculations, in order to calculate the molar solubility of our calcium hydroxide and our KSP of the same calcium hydroxide, we are gonna start with our moles of HCl. So we have these amount of liters already calculated, and we have the 0.05 that we started earlier. We're going to do this calculation and division, and this is going to be the amount of moles of the CHL that we have. So then for our moles of OH in our solid solution, we're going to be using this equation. We're going to take half of our moles, and we're going to end up with 0.00445 moles. Then we have one more step, that's going to be our equilibrium. So we're going to take this amount of moles of the OH, and we're going to divide by our 0.025 liters. That's a amount of liters already calculated for calcium hydroxide, and we're going to end up with 0.0178 moles of the OH. So now for the molar solubility, we're going to be using this equation, and we're going to take half of our OH already calculated. So we're going to take half of the 0.0178 molar calculated, and we're going to end up with 0.0089 molars per liter of the OH. So we're going to take half in order to solve for the molar solubility. And now to calculate our KSP of our calcium hydroxide, we are going to be using this equation. We have KSP equals half of the OH elevated to 3, and we're going to do KSP equals to this number of the OH calculated here for the equilibrium, and we're going to elevate that to 3. We're going to have our result, that is 0.0000563, and then when we take the half of this number, we're going to end up with 0.0000282, and that's going to be the KSP for our calcium hydroxide. That's how we solve for the KSP of our calcium hydroxide.